Alright, we're in our last lesson of the unit. Remember, our unit is on parallel lines. However, you know that when we've been talking about parallel lines, even when it's with the equations, perpendicular always ends up coming in there. So if you see that symbol, remember upside down T equals perpendicular. So we have two rules of perpendicular lines that we're going to talk about in this unit about parallel lines, because again they're opposites, right? Parallel lines means the slopes are exactly the same. Perpendicular means they are opposite reciprocals. So we're going to talk about two different rules of perpendicular lines. Alright, the first rule, rule number 1, okay, states this, that the shortest distance between any point or any points is a perpendicular line. Okay, so for example, let's say that right here, this is Mesmer, okay, and you're standing here across the street, okay, and you have some options. So you could go from here and you could go to the corner. You could start here and you could go right to the front of the building. Or let's say you go here and you could walk over to the end where the bridge is. Now clearly we know that the shortest path is going to be from here right to the front of the school. And you can see here that this point and this line is making a right angle, or it's perpendicular. So the shortest distance or the quickest distance between a point and wherever you're trying to go to is going to be a right angle or is perpendicular. So if we named this, let's just throw some letters on here. So what they'll do is they'll ask you what's the shortest distance or the shortest segment between the point and the line. Well, AC would be your shortest distance. Okay, now you may see another one. Let's say that it's over here now. We have this triangle, something like this, and they'll throw a line in here. And so they'll ask you, just again throw some letters on here, what's the shortest segment in here? And you would say HL is the shortest segment because HL is the one that forms the 90-degree angle, so HL is the shortest. Okay, so that's real simple. First rule is the shortest distance between 2 points is going to be perpendicular, which remember perpendicular is going to form 90-degree angles. So AC and HL would be your shortest points. Alright, next rule, and the last rule, is going to be that the hypotenuse, we're going to hypotenuse, so we're going to go back to a triangle. Hypotenuse is the longest side of a right triangle. Now, we should already know that, but we're going to use that rule to help us with how to set up these problems. So, let's draw a right triangle and refresh our memory on what the hypotenuse is. So, the hypotenuse is over here, and this is the longest part, which is across from the right angle. So here's your hypotenuse. I'll label that with an H. And over here, these are your two different legs. Okay, the hypotenuse is the longest. So how this goes in with perpendicular lines is right here. You have perpendicular lines, right there. And so let's say that they threw some values on here, and they said that this leg over here, the vertical leg is 5, and the hypotenuse is x plus 3. And they're going to ask you to set up some kind of equation to figure out what could x be. Well, we know that the hypotenuse is the longest side. So we know that the hypotenuse has to be bigger than the leg. And why I'm putting this as an inequality is greater than. So the hypotenuse has to be bigger than the leg. So if we just plug this in, the hypotenuse is x plus 3. So I'm going to plug in x plus 3 is greater than the leg, which is 5, and then if I solve the inequality, is going to be x is greater than 2. So my answer here, how can I figure out what the hypotenuse is? Well, you know that x has to be bigger than 2. So it can be any value that's bigger than 2. 3, 4, 5, 6, because the hypotenuse has to be bigger than 5, because 5 is one of the legs. Okay, let's try another one just to make sure we got it. Let's say we have a triangle like this. Okay, this is going to throw you off a little bit. So we have this value right here is x minus 5. Alright, and then we know that this over here is 2x minus 20. Where's our hypotenuse in this situation? Okay, the hypotenuse is right here. So we're looking at the smaller triangle. So this is your hypotenuse, and this value would be your leg. Okay, here's your right angle. So remember, our equation is the hypotenuse has to be greater than the leg. So your hypotenuse is 2x minus 20, so 2x minus 20 has to be bigger than your x minus 5. And from this point then you would just solve for x like in inequality. So I'm going to subtract x on both sides, and I'll get 1x minus 20 is greater than negative 5. Add 20. So x has to be bigger than 15 in order for this to be a true statement. So those are your two rules for perpendicular lines in our unit. And we are done.